Hello, everyone. My name is Flament-Wallin. I currently work as a software/systems /backend and cloud engineer in Haptic, a Norwegian game technology startup that develops a platform as a service for virtual work training. And I'm really thrilled to be here this afternoon with you. We have a lot of cool stuff going on at Haptic at the moment, and I could definitely talk about that, but that's not the topic for today. So just to preface, this is not a technical talk about any of the many machine learning algorithms out there that others have touched on. My talk is really directed towards you, data scientists and software engineers and others I know is here, and anyone else AI curious or who works with or within AI in some capacity or other. I'd like to share with you just briefly a bit of my background and some snippets of lessons from different fields and that I feel informs or should inform AI, and to advocate for a more multidisciplinary approach to AI. I recently saw a tweet that said something along the lines of, are you multidisciplinary or just unfocused? Now, obviously, that's a stab in the heart for anyone who ever felt like they were too much all over the place, like a jack of all trades, master of none. But I think that as developers and data scientists necessarily have to specialize in sometimes ridiculously niche things, even within their field, for very good reasons. Those of us who have backgrounds or insights that might not be the norm or as pervasive in the industry or the field we're in, we really we have an obligation to help lift our peers' point of view from time to time, because we all know the importance of continued learning. I think everyone here probably feels that. But we tend to focus heavily on technical courses, new frameworks, libraries, etc., certifications, and because ultimately it is pretty powerful, the systems that we're developing, the products or services that we're making, at least in my case, and I'm sure in many of your cases as well. We really are transforming how people work, live, move, socialize, etc. And as we've gotten, I say as developers, data scientists, systems designers, have gotten this really kind of all-powerful role in society as cloud architects, devs, etc. Maybe more and more so. It's good to remind ourselves that in addition to programming languages and tools, people with a heavy math or physics background might really have something to learn from the engineering department that you maybe didn't have a chance to before. And I think we already see this in the emerging AI ops movement that's taking learnings from DevOps and applying it to the process of getting machine learning models to production, etc. And B, for those of us who have an engineering background, engineering is not everything. We're practical people, but for every big societal problem, the solution might not be engineering, or at least not alone. And we really need to be humble or respect that feels like sociology, linguistics, psychology, philosophy, might inform us much more than we consider on a day-to-day when we're naturally trying to solve very practical problems. So just briefly, my background is from computer science, and I've always been sort of drawn to AI. So within computer science, which is a huge field, I majored in something we call human-computer interaction, which in itself is a multidisciplinary field within computer science, lending from, like I said, sociology, psychology, etc. And using this to design for good user experiences. Yeah, I took courses in language philosophy, computational linguistics, which is what we use in natural language processing, and machine translation or chatbots, etc. I took courses at the psychology department in cognition, perception, etc. Well, as I wanted to get more into AI, UX or UI was didn't feel like the path for me. But anyway, I think we all know kind of this path to data science or AI more broadly. You study physics, math, or maybe statistics, learn Python programming, or maybe R, something like that. And you become a data scientist. And so I'm here to advocate for a much wider range of backgrounds to inform design decisions in AI. Almost no matter what your background is, you should probably work in AI, basically, is my takeaway. That is assuming we can agree that user-oriented design made by people representing many different needs and walks of life makes for better, more robust systems, less prone to all kinds of bias we might not pick up if the developer pool is too homogeneous. And as AI-infused systems become more and more widespread, I at least believe that more unique perspectives, and more in general, is very much needed. So without further ado, let me share with you some things that inform me in making more or less intelligent systems. So a bit of what software engineering has taught me. So as a traditional data scientist with a background as described earlier, chances are you haven't had the opportunity, perhaps, to learn that much about software engineering. You might not know like many of the truths we software engineers all know. For example, that estimating tasks is almost impossible. That it's well documented that software development projects are approximately 30% above budget at least, and late. Maybe you work within like sprints and have stand-up meetings, but if you don't know where these terms come from, they're really they just sound like dumb, silly words and annoying meetings. If you don't know the history of, or at least a little bit of the agile development movement, you don't know why we moved away from the waterfall development process in the first place. And I speak from experience when I say that this kind of lack of historic insight leads to using the waterfall development process model. And surprising to no software engineer, I should say, this leads to problems. For example, it leads to that testing of AI systems is done much too late. This is one of the motivators of the whole agile movement to begin with. So like I touched on earlier, there is a movement now that has emerged something years called AI Ops, as in DevOps, but for AI. And this is an attempt to take learnings from engineering, from Agile, and from DevOps, and apply it to AI. In any case, if some or all of these words, DevOps, etc., are kind of just like techie words to you, I urge you to go to agilemanifest.org and read it. It's very short, and like don't be afraid to take a little software engineering history lesson. Moving on to what design has taught me. So if you're a data scientist or a software engineer, chances are you don't have formal training in user-oriented design, for example. Perhaps you've learned the hard way that customers or users, or both, cannot be trusted to hand over requirements for you to implement. They're just not able to do that. You start implementing the requirements that you have gotten along this stuff, and more often than not, it wasn't what they wanted. And if it was what they wanted, maybe it was not what they needed. As a software engineer working alongside data scientists, I've seen this happen, and again, it's not really about testing if the program or system, whatever model, if it works, but making sure to test if it does what it's supposed to do. A little story to illustrate this. I once worked alongside two very excellent data scientists who had been tasked with making a predictive milk production model for Norway. They went to work and came back with a model that could pretty accurately predict milk production per municipalities in Norway as per the requirements. Well, it turns out, for many reasons, that that was completely useless and not what the customer had wanted or the user had wanted. The customer assumed it was obvious this had to be done on farmer level, but it was not. So if you're a data scientist, you're also a software engineer, perhaps, at least to a certain degree, a designer, at least a systems designer. And that, while that doesn't mean you have to start, making wireframes and think about usability or eye tracking or any of that stuff, but be aware that what you make up for in math, you may lack in design thinking. So lending from anthropology for data gathering and being user-oriented can, I believe, save you years of your life. So if this, struck a chord, I urge you to watch a very classic video on YouTube. It's a 60 minutes episode on the famous design agency IDEO. And also check out Don Norman's classic book, The Design of Everyday Things. But probably most importantly, sometimes when we're like too caught up in asking, how do we do this? How do we make this work? We forget to ask, why are we doing this? Which is also our job, unfortunately, sometimes. As I mentioned, I studied some psychology, and this is a field that has been and still is extremely influential in AI. I think it's worth kind of noting. Even the term intelligence is something that we don't really know what it is, but we use it and we try to make it. And we can probably, learn a lot of things from psychology, which tries to study this. So when you think of psychology, you might think about like feelings or Freud or therapy. And that's true as well, but psychology is a huge field, increasingly intersecting into biology. And I find it useful to have studied perception and cognition as a systems developer, because it's about how humans process information. That's really what it's about. It's also useful to know a little bit about what little we know about memory, human memory, and really how the brain works. For example, one of the most buzzwordly machine learning algorithms, or maybe not algorithms, but paradigms out there, neural nets, was inspired by a theory of how the brain works. So this is a 1950s theory, and I think it's necessary, actually, as data scientists, to know that a lot have happened in the brain sciences since then, because more powerful computing gave us the AI boom we're in right now, and really made it possible to implement neural nets for the first time on a big scale, etc. But did we take the time to ask if this is even the best or even a good model for learning? At San Jose State University, my perception professor was working in a design team at NASA. He now works at Google. This is to say that engineers really need more perspective, let's say, than math and logic to make these systems. Or we need more than engineers to make these systems. Is what I'm trying to say. Moving on to what linguistics, or at least computational linguistics, has taught me, really both. So I'm sure many of you recognize Bayes' theorem that we have here. That's familiar to anyone who has worked with statistics or whatever. And in natural language processing, it lets us find the probability of a word given another word, for example. And this is used in machine translation and other applications. But machine translation is not a solved problem at all. Natural language processing turns out to be really hard. Written language might be our most genius invention, some people argue, but we don't really have a manual, or it's been lost. And even if we, as someone pointed out earlier as well, we can tag every last word in every language in the world, and we still would not be done. And this is because language is alive and ever evolving. So natural language processing, or NLP, uses advanced statistics to predict words and sentences, but it is very hard to predict words that the machine doesn't know. And this problem is not only a conundrum for natural language processing, by the way. In any, really any predictive system used by retailers, in cookies, in the web browser, etc. It's really hard to predict whether customers would be interested in buying whatever product if that product has never been in stock, or at least just by looking at the data. I think everyone can relate to buying a product and then being bombarded with ads for that same product for weeks later. It's like I already bought it. I'm not going to buy another camera that's exactly like the one I just bought. But this is really because it requires us looking kind of outside of the immediate data, let's say, in order to try to predict, like, okay, Julia bought this camera. What else might she be interested in now? Or in this problem, that's very much still a problem. Perhaps Pierre Bourdieu's theory of capital and class distinction can inform us more about human motivation and behavior than Bayes' theorem. Maybe we need to look to sociology in that case. So again, if this struck a chord, the next time you're bashing your head against the wall trying to implement a chatbot, maybe take a break and read The Unfolding of Language by Linguist Guy Deutsche. Moving on to what history has taught me. Have any of you noticed how no one talks about big data anymore? I feel like it was like all the rage some years back, but now all the conferences have different names, and what happened? I think there was this huge optimism surrounding cloud and powerful computing, that if we just had enough data, or a lot, we can answer all kinds of questions, and we can answer questions we didn't even know we had, etc. And well, I think we can kind of land on that. That was really not the case. Now, sometimes we might really be using big data, but the point being that we can't just feed big data or a lot of data into some model and like expect results or answers. And oftentimes, also as noted by several other speakers today, more data is oftentimes not the answer or the problem. A long time ago, I thought I was going to be a history professor, and I enjoyed history a lot. That is, not memorizing, years and events, but how events, countries, or whole cultures could be understood by what led up to like current state. I was, motivated by understanding human behavior and our societies, but history as a field has taught me a few things outside of history itself. Namely, one trend usually follows another trend at the completely opposite side of the pendulum. And as architects and again, systems designers, I think this is very useful to keep in mind. For example, microservices as a pattern directly follow the monolith architectural pattern paradigm. Now we might be a bit more pragmatic in terms of that specific architecture pattern. But what other trends might we be victims to right now? NoSQL was kind of supposed to replace SQL, or at least some people claim that. But it turns out that we probably need both, but for different purposes. I have a quote here by a Polish journalist, poet, and author, Ryszard Kapuscinski. I probably don't pronounce that correctly. Reflects on history as a field and what it means for a journalist like himself in Travels with Herodotus. And not only history at face value, but how it was written and who wrote it. And I think we can gain a lot from doing the same in our field of AI. Again, think about neural nets as an example, as it's meant to work the same way the human brain works. Where does the models we use today come from? In what environment did they come about? How valid are they today based on our understanding of human nature now? So history can teach us to be critical of today because of yesterday, and at the same time be critical to what we think we know about yesterday because of who wrote that history. At least it's definitely taught me to stay a little skeptical about the biggest buzzwords that are around at any given moment. The problem with the world is that fools and fanatics are always so certain of themselves, and wiser people so full of doubts. I think that a lot of people have seen this now infamous quote by Bertrand Russell, and any logician knows Russell's contribution to logic, and many knows that he was an outspoken atheist. But did you know he was an avid pacifist, actively trying to avoid World War II? Now, obviously, sadly, he didn't succeed in this, but curiousness outside of his own field made him able to look at the world outside of mathematics. And as developers, we all feel the pressure to get ever new technical certifications, and that is important. But if you're an engineer, come from STEM or really anything other than the social sciences, chances are, although you work with data, you haven't had the chance to study how or why bias in datasets compound. On a serious note, and also as many have touched on today, there are now countless real-life examples in production in various systems out in the world today to show the state of ethics amongst engineers. Self-driving cars that are less likely to classify dark-skinned people as humans, as a grim example. I read yesterday that autonomous cars are dead. Now, while I don't necessarily agree with that statement, I think it's worth noting that, for example, Lyft has the tech ride-sharing company has taken a complete 180 and sold out of all of their self-driving car investments. And I think that says something about how the promise of the self-driving car was perhaps rushed. And it's clearly not enough to make models that work. Robustness in AI has been mentioned. And maybe we really should take some time out of our year to take an ethics course next time. Wow, I'm running out of time. Let me wrap this up. So I know that everyone can't learn everything. It's really not possible to be a Renaissance man anymore. But my point is that we as systems designers need to be humble to the fact that there's many holes to our knowledge, and we don't know what we don't know. So we should definitely take inspiration from other fields on the other side of campus, etc. But since no one can know everything, we should really want to diversify the background of the people in our teams for this reason. Much like there is already a culture for in design teams at IDEO or other product design teams and agencies. With that being said, I think that's it for me. And yeah, do reach out on Twitter, LinkedIn, Slack, whatever. And thank you so much for your time.